I've been a bit busy with some things lately, so this is my first in a while. I have been hacking away on the solar source, trying to add in some graphical capabilities, graphics, and also display objects. So in the graphics side of things, I have some custom commands that you can register, which will be injected into Solar's actual rendering system. So this will allow you to execute actual OpenGL code, for instance. There's that. There's some things you can add to that, such as clearing, which should be, for instance, clearing the screen or clearing another kind of buffer that you would append another bit of logic to that, so that when the renderer did a clear operation, you would do not only the basics but custom stuff as well. And I'll go into what those are. These states, so that's basically I've updated something important that doesn't belong to the sort of geometry that's currently rendering. So stop doing a batch, update this state, and then go on your way. And actually sending the commands, because you can. There's stuff for registering and then for sending stuff along. And there's also this begin. Where is it? Begin frame. So you can schedule things to be for the next frame, so that if you did something that needs to be cleaned up, you want it. You want it to be cleaned up the next time around. So, for instance, if we set an OpenGL state, then we don't want to leave that. Best case scenario, we would be cleaning that up ourselves, but we might miss something and leave it behind. So this is kind of a sanity check to clean it up when the next frame rolls around. So those are the building blocks of what I'm showing. Well, I didn't anticipate this happening as I was recording. So another thing I'll show here is that there's the ability to add customizations that will replace what the built-in will replace what the built-in shader code provides. There's a shell, it's called, and I'll see if I can get that. So most shaders will generally build around a GLSL shell, and the kernels will get stuffed into these bits here. Well, they're declared here, and then they get pasted on either at the end or in WebGL. You'll inject it into the shell itself. And then there's all this state around it, for instance, to declare positions that you're going to use that come from outside, and how you're going to, or these various variables that are provided to the shaders and how they're exposed, and how the kernel expects to receive input and what it expects to output. So that's all available, and this capability allows you to edit that. And the whole philosophy behind this is that we have the source now, so there's no point pretending we don't and acting in a black box. So you can write a plugin using these features that will let you use the knowledge you have of the source and revise certain internals from there. And then there are ways to add variables that your shader or your instance of a shader might expect and use it. And then ways to revise the actual drawing itself. And there's some stuff in here for matrices. And then for mapping bits of geometry data so that you can send information between them, between your input geometry and the output geometry that will arrive. So it's a way to establish a correspondence between those and make use of that. Then this other bit is we can make our own display objects. Either so far I have rects polygons, although I don't know if I've got that right yet. Meshes, groups, and snapshots, although I haven't done the interesting part with that yet. There's some things I haven't implemented here. There's a get parent, get child. These give you a handle, so you can't access the internals itself, but you can use this to look them up later. These are short-lived references to objects. And I also have that kind of thing going on with the renderer itself and some shader state, this and that. I added a method called sendMessage to display objects, so you can explicitly send one to yourself by yourself. I needed this to do some communication among them, and finally we have all these events. So these are basic internals of display objects, which is added to parent, drawing, scaling, translating, pairing. There are a few others like this, and you can either eliminate the original behavior. Sometimes you can, or in most cases, you can add something before it, something after it. So when you draw, you can avoid doing the original drawing, but you can add an event that would happen beforehand or after. And often this will be to sort of sculpt your own objects. So you won't even do you'll have a rect, but it won't really be a rect. It'll just be some object that's in the display hierarchy. And when it draws, it does some action at that time. And that can be as simple as setting a state. there's the get value and set value, so you can add your own properties, and some of these have early outs. So if you did assign something, or if you didn't assign something, you can choose one or the other and say, well, you know, I assigned something, so we don't really need to do the rest of the behavior, or vice versa. You know, I didn't do anything, so we'll just leave it at that. There's nothing to do, even though a normal object would want to do, say, set x or set y, or get them and get that sort of thing. So we can build up a whole stream of these and attach them to an object, and then when we push our own version, it'll execute according to that. So that's all the internal, or that's most of the internal bits. I've built several things on top of those, and I'll show. I don't think I'm going to go into the code for those, but I'll show what they look like in action. We'll start out with, I don't know if this is quite complete yet, but it's getting there, because some of the output looks a little fishy, like the states aren't balanced. So this is render states. First of all, I added some things you can set a stencil size in the settings, and it'll build your Solr instance using that. So it'll allocate a stencil buffer, and that way we can use a stencil. I've got something called scope group object, which is a group, but it sends a message before it draws and after it draws. So I'm using those things I just described, and it'll go through its children one by one and tell them, hey, I'm gonna draw right now. Or at the end, it'll go in reverse and say, hey, I just finished drawing. And it'll do a new every round. Every frame, it'll increment a counter and send that. So you can say, okay, I got this message, so I'll push some state on a stack, and at the end, I'll peel it off to restore whatever I did. So it's a way of causing state changes, but you get informed that these are happening, so you can undo them. For instance, what I'm doing now with color masks. So these let you turn off rendering to a specific channel. Like you can turn off renders to red, and nothing that draws while that is in effect will use the red channel. And usually you wouldn't do it selectively like this. You would just turn all the channels off. So you would render, but you wouldn't render anything graphical. You wouldn't render any color. You would just render any other states that were on. For instance, depth or stencil. And that's exactly the whole reason behind binding that was for that reason. But the sample will actually do you can see it's doing just specific channels, so it's turning off red or blue or green, and cycling through them actually. So there's a timer. It starts by turning off blue, but then it turns whatever it wiped out back on, and then turns a new one off. And so it's doing that with all these things that are in the group. They're between and then the color mask gets restored at the end. And I only just added animation of sorts to this, so I need to check if everything is working out. But so beyond that, we're also doing some stuff with stencils, and we have an object that's rendering to the stencil buffer, and it's just using replace. So replace with stencil of 1. So it's blasting that value where it draws with the value 1, and we have another object that is using those same values. It's saying, am I not equal to 1? And that's so I need to refresh myself on stencils, but I believe that's the only time it'll draw is if it's not equal to 1. So it's masked out by that part. And to that effect, we scale this slightly larger than it would be, so it will. And these two objects are the same size. So one is drawing the stencil, and another is detecting it. And the first state turns on stencil writes. The second state never had that, so it's going to be false. I believe. Like I said, I might have to go over some of this a bit more, but the upshot being that you see this rectangle in the upper left corner where the red, or whatever it's color masked, object going back and forth will occasionally get obscured by this other rectangle there, which isn't actually drawing, it's just rendering the stencil itself. But when that goes, and that object is actually drawing over that other object, but we never see most of it because the stencil is covering it up. So that's stencils. Then we have instancing. And so this will, if we do a quick, I'll quickly show this. We see three objects going up and down, and they're oscillating in color a bit. Now, and you see a counter down below, so it's showing that the instance count is originally 0, which just means no instancing because it'll still draw 1. But then we assign a count of 3, and we'll get that back. So it's just showing that works. But the idea is this is just a single object. But it'll get drawn 3 times, and based on whatever the current instance counter is, it'll get shoved over to the right a little bit, or up and down. So we have a sine wave going on, and then the plus translation in the x direction. And the color is also using the offset as a bit of, the instance as a bit of an offset into that oscillation we see. This is also doing some somewhat interesting things. You can see how we're doing something to look up this property, and it's getting assigned to a special region we've allocated. And so this is ignoring the original draw method and putting another one afterward. It will first draw one instance no matter what. So it'll still do the normal behavior if you haven't specified a count. But then it'll also update the Z channel, which has always been available, but it's not really in use. And it'll update that with 1, 2, 3, 4, etc., and then draw again as many times as you need. Then reset the index to 0. And here's where we do some setup to get the access to that attribute. Oh, did I? I don't think I showed that. Here we'll add a customization. So that means we're doing some code, some changes in the shader shell, and we provide some info to it too. So supports instancing. It'll look for that, and it'll say which channel we're hijacking. So we're hijacking the Z channel, and there's been a Z channel for a long time, but it's not really put into any use right now. I think it was for some 3D experiments that were in there, and then never got put into practice. So that's what's creating this correspondence. It'll use that channel that we gave it. So Z in this case. And here is what our shader rewrites look like. There's some helper stuff I created. So it'll look for vec2, a 2D attribute position, and change it to a 3D attribute position, or position attribute. It will look for this part where the user data are being set up and assign the instance that, use that as a useful point to put something. So after that, we'll assign the instance index, and we'll, now where do I have that? And we'll also, since we have a 3D position, but we still have a 2D kernel, we're not doing anything 3D, so we'll just use the first two components of the position when we call our kernel. Here's the things we see in the code where we're actually using the instance index. So they're just these macros over it, and using a varying. This is the V position is not being used, so I'm actually replacing that. That just makes sure we have enough varyings. But this goes into both the kernel and fragment source. This other stuff was just fragment, or just kernel, or not kernel, vertex. So there's some code that goes into each, and there you go. So that's what I do to adjust the standard form of the shader to allow this instancing feature. And that basically, when that doesn't work, it goes badly because it's sort of expecting the shell to be well formed and to compile. So I don't know, maybe that wouldn't show up if I wasn't in the debugger, because the debugger doesn't fail quite as gracefully in some ways. I think certain things are turned off. Lastly, this is very early, but it's doing the same thing with another customization. This one for 3D. I don't have a very good example to see if the everything in my shader is what I want, but we'll go into that later, or I'll look at that later. So this is like the stencil object basically. So I have a depth state that I turn on, and then I assign projection and view matrix, this sort of standard stuff, and then I'm updating where it's looking from every frame. So it's just hopping around. It's not very lovely. Meshes, I'm adding Z to every component, but otherwise it's a fairly normal mesh, and just telling it has a Z component. So that'll take care of some of the plumbing later on, and then just simply assign the effect as usual. And to go over again what I did, I have let's see, depth load. I believe this is where I have it. Right, so So I'm updating the source in a similar way. This is, again, this is actually a small one. It's changing from a 2D to a 3D position attribute. And similarly, well, in this case, the actual results of the kernel will be 3D. And I didn't need to change how I pass it to the kernel because the kernel will now be expecting a 3D position. But the kernel itself has to be updated with this signature. And I'm doing this multiple times because there's multiple uses of the positions, and I had to. The unfortunate fact is that you have to kind of count them and know what they are. But then some of the masks, they will expect a slightly different assignment. The mask transforms that are in there, and lastly, how we finally transform our position according to the current projection view transformation in effect. But on that note, we have everything in there that we need. So here we go. And this is just some random rectangle in the middle, but I was having a hard time. I just wanted to make sure something was appearing at all. So we have that, but then everything else is in 3D, and it's not perfect yet, but it's a perfect concept. What was happening was that I was clearing the depth buffer in the wrong way. I was clearing it to 0, but by default you want it to 1 because everything is going to be less than 1. It shows up. But so this is our mesh, and it's not moving, but the camera is. The camera's just jumping around, but I'll try to make something a little more elegant after this. What else? The polygons, in theory, will work, but I tried it with those, and I was not getting anything appearing. So there must be something missing with polygons. But I do have them taking in 3D input. They're similar to meshes, but they don't. Instead of having a table member called HASI, you have an extra boolean at the end. But they're not. I'll have to dig into that because they'd be another obvious way to do this. Well, on that note, I'm going to leave it there, and I'm hoping to make quite a bit more impressive sample here. I'll have a camera actually moving around, I hope, and then maybe the object itself actually rotating and loading from an OBJ. But we'll see. We'll get there when we get there. So I hope that was interesting to some, and I'll see you later.